Hey everybody, I'm Nick Matthews. I'm here today to teach you about networking best practices and tips with a well-architected framework. I do network stuff here, and today it's sort of the whole idea is we're going to teach some tips and tricks with high availability and networking, all those kind of things. So we're going to go real fast. This is sort of like another way of saying, like, if you sent me an email and said, "Hey Nick, does my network design look good? Look at these diagrams." This is the type of stuff I look through and the types of things I talk with customers about pretty often. About hybrid and sort of VPC networking. So let's get into it. So the way we're actually going to organize this is through the well-architected framework. It's got 5 pillars that you can see here, and so we'll go through each one of these pillars and talk about best practices for each one. And so yeah, let's get started here. We're going to start with reliability. We're going to start with the dark arts of networking, because keeping networking up is it's hard, and it's a bit of a secret magic to other folks. So if we actually start from the top on availability, the way we start is with, obviously the AWS cloud in general. Our cloud is made up of regions. We've got 22-ish, I forget the exact number because we keep adding more regions, regions around the world. Those regions are isolated and segregated, so one issue in one region doesn't affect another region. And so when you think about this, there might be individual services within those regions that can have a bad day. And so how would you start architecting your network to handle those types of failures? So it depends on how you're coming into the network. If you're coming in through Direct Connect, you can use things like Direct Connect Gateway. So the Direct Connect Gateway is essentially an entryway to our backbone. So you can get from one location like Virginia into places like Virginia or Singapore or Dublin or Frankfurt. And so the Direct Connect Gateway allows you to connect to multiple regions from one physical location. And so if you're using multiple regions for disaster recovery or latency reasons or geographical reasons, make sure you're using Direct Connect Gateway there and connecting to all the regions where you have AWS resources. If you're coming in over VPN, it's a very similar story. Make sure you have tunnels to all the regions that you're going to be using. In some cases, Direct Connect may not be cost effective, and so you may have a mix of both Direct Connect and VPN. And so then we start saying within a region, what are some other things there that we want to think about from an availability perspective? Availability zones are a data center or likely multiple data centers within the region. Each one of our availability zones has separate power, separate cooling, and often like different sort of control planes. And we try to treat our services, in availability zone specific ways. And so if you're going to see failures, more likely they're going to be at an availability zone level. And we start talking about the types of failures. It's more of a rainy day than it is like some sort of binary on-off type of thing. So it'd be like higher degradation rates or slower latency or those kinds of things. And so it's not just like, does the availability disappear from the face of the earth, but more of like that one particular availability zone might have issues. And so from a networking perspective, what do we need to think about when that type of thing happens? Well, a lot of our services are built per availability zone. And a lot of the resources you deploy are also a per availability zone. And so you want to make sure that if you've got, this application that's running in multiple availability zones, that it doesn't have dependency on a single availability zone. So some of the examples here are NAT gateways, EC2 instances doing routing, single tunnel VPNs. So here we've got pictured one NAT gateway running in one availability zone. If that availability zone has a bad day, well, all your instances in a separate availability zone that's running fine now also have issues. So you've created dependencies there that you probably don't want. A lot of customers also run like firewalls, VPN servers, those kinds of things. A lot of those things are sort of relics of like on-premises networking designs. And often they have like single availability zone designs because they weren't designed to run maybe in the cloud or not really configured to use multiple availability zones. And so if you're using these types of things and you're pointing them from another availability zone, you've got an availability risk there in case something happens to that device or that availability zone. As well, so with AWS's managed VPN, we provide 2 tunnels with every VPN connection. If you get the tunnel up on one tunnel, go, yeah, okay, great, everything's working. But the second tunnel's not up, you have an availability risk because if that availability zone where that tunnel terminates has a bad day, well, you're not using the second tunnel. So the way this looks like when you solve it is you put all those devices in multiple availability zones. So you'd have a NAT gateway in each availability zone that you're operating in. If you're using virtual routers or firewalls, make sure you're using the availability methods that do use multiple availability zones as opposed to a single availability zone. And then if you're using the VPN gateway, make sure you're using both tunnels because those are going to go to, again, 2 different availability zones. And then some other things that can happen here from a networking perspective is your direct connect location. So we've got these multiple regions, they're segregated. You have availability zones, which are multiple data centers. Great, you're using all that stuff in the cloud. And you've got a single direct connect location. That's basically a single building. You can have power problems, you can have electrical problems, you can have, I don't know, actual flood problems, who knows? It's a building. And one of the most common issues I see with customers is they will, it takes some time and planning and everything to find this location, get circuits there. I get that. And so a lot of customers go, well, let's make this more redundant and add a second location or a second circuit to this. Well, now you've got multiple circuits coming into one direct connect location. You have multiple routers. Now it's connecting globally into our regions, but you're still dependent on this one building. And so this is probably the most common issue I see with designs. And you can choose to take this, but just know that's not an AWS recommended best practice. What is something like this, where if you want to run 2 circuits, great, run them to 2 different locations. And then those locations can then come into our backbone and our regions in 2 different ways. And so this starts making you eligible for SLAs. If you want higher availability and more resiliency, you would do 2 devices at each at 2 different locations, so a total of 4 circuits. So if you take a look at the actual SLA, for 2 locations, you can get to 3 nines. If you have 2 locations with 4 circuits total, you can get up to 4 nines. We have the SLA described here on the website if you want to get the details. And for VPN, it's pretty simple. Just make sure you're running on both tunnels. You can use those for backup if it maybe is too expensive to get 2 different locations. But please have a backup there. We do have a failure toolkit for testing, so you can simulate direct connect failures, those kinds of things. And there's a link here. All right, so we've taken a look at the region, AZs, and then the direct connect location. So what's going on inside your data centers? So you probably have BGP peering for direct connect into our direct connect gateway. That device in your data center can have a bad day. If you're coming in over VPN and you're using both tunnels, even then you can have a bad day there. And so what we recommend to do here is to put in a second device. So there's also protocols like bidirectional forward detection or BFD that you can use. So with direct connect, you're using a second circuit, use a second router. You can enable BFD, which enables faster failover times. So you have less downtime if there is an issue. And then over VPN, you add a second device, add 2 more tunnels, and bring that in. So whether that's coming into transit gateway or the managed VPN per VPC, you'd want 4 tunnels coming in from your data center. So yeah, another thing I see here is I get these diagrams from folks. They say, "Hey Nick, how does this look?" And it's like this slideware Visio type thing that someone's tried to sort of combine what they know on premises with what they have with AWS. So they have the mix of their on-prem Visio icons with our VPC stuff, and you get things that look like this. And me as a AWS networking person, I just go, what's really going on here? I can sort of tell by the diagram that you haven't tried doing this yet, because this has some challenges that aren't immediately visible from just looking at the diagram. So let's walk through one of these sample diagrams and what this conversation looks like. So let's start with a central ingress VPC. You want all the internet coming into one place. That gives you the warm and fuzzies. Great. Okay, well, how are we going to distribute that traffic? Are you going to use our load balancer? Are you going to use a third-party load balancer? How are you going to handle the sessions coming in from there? Are you going to put multiple ports? Or are you going to do multiple SNI and server name indication mappings? Or are you going to do maybe some layer 7 processing? How are you actually going to have maybe potentially tens or hundreds or thousands of applications through one set of load balancers? That's a complicated problem. Plus, when you come into firewalls, those sessions are going to need to keep going through the same firewall each time. Otherwise, you get asymmetric routing. So you have to worry about session stickiness and probably doing some NAT. On the firewall, then you say, okay, well, I've got these tens to thousands of applications. how am I going to map that to incoming sessions from the load balancers? Are you doing, again, more NAT? Are you doing layer 7 proxy level stuff? But it's fairly complicated to actually map all those things. The next layer is, okay, well, how does the firewall get into your VPCs? Typically, you put a load balancer, you put a target within the VPC, you're straightforward. But now you've got this firewall that needs to keep track of where all these applications are in other VPCs. So either you're doing static IP address mapping, which means you have to keep up with all those things and reduces your scalability, or you're load balancing to a DNS name. Firewalls historically have not been that great at natting to domain names, although some of them can do that now. And so you have to solve that problem. As well, I mean, just operating firewalls in this manner, if you're putting behind a load balancer, which may be able to auto scale up and down, are you ready for that? Like, do you have the discipline and the operations for firewalls that may scale up and down? Because if you're manually touching your firewalls and manually configuring them, and yet there's this automation involved, like how are you going to make those two worlds agree with each other? And so this is actually what I would recommend. And this is a brand new design, so it's the first time I've presented this. And it's great because we just launched Gateway Load Balancer a few weeks ago. And what this looks like is this. So you sort of start down the lower right, use the ingress routing feature on your internet gateway. And you say anything that comes to the internet, send to my Gateway Load Balancer endpoint. It's sort of like private link. And it is an endpoint which will then redirect all that traffic up to this central inspection VPC up top. So the Gateway Load Balancer is going to be doing the session stickiness, so that means you don't have to use the NAT here. And then it's also going to do the health checks to the firewalls. It's going to do that across multiple AZs. It's going to handle a lot of the hard parts of that for you. So the firewall does its firewall stuff, sends the traffic back through the endpoint into the VPC. And then on a per VPC basis, you can basically say, hey, I want to punt all my traffic to these central inspection firewalls. It comes back to the VPC. You've got one place to manage the firewalls, and you're not having to worry about some of these more complicated load balancing stuff. So it's a great pattern. Really excited that we have this now. And that's all brand new. So then we get to, okay, so we've got something for that pattern. What about this stuff here on the left? The shared services VPC, where we're going to have some incoming SD-WAN, which goes to a load balancer, which then gets inspected by our firewall. Sounds great. But how are we going to make that work? So same thing. If you have SD-WAN maybe on your edge from your branch sites or whatnot, how are you going to spread that load? How are you going to keep those instances up and available? Who's doing the health checking on that? Sometimes it's the SD-WAN system, but sometimes it's just not there at all. This load balancer, again, we have the same symmetry and NAT and health checking problems that we had before. And then the firewall is then also, we have to worry about these asymmetric routes again. But not just that, but just the operations of this, which is if you've got traffic coming through like 3 different sets of appliances on a shared network, if you have issues, how are you going to figure that out? Is it the load balancer? Is it the SD-WAN? Is it the firewall? Is it the VPC? Is it an instance problem? And just like the operational aspect of trying to figure out what's going on there can be really complex. And so typically this is closer to what I'd recommend, which again, we've got this great gateway load balancer thing, so we'll reuse that. It solves a lot of our health checks, AZ, reliability, and scalability and symmetry problems. And then what I typically recommend folks to do is start off with either just the SD-WAN or just the firewall component. It's less moving pieces. A lot of the features between those two different types of products are now getting more and more similar. And so by sort of choosing one device that can do a little bit of everything prevents a lot of these operational issues. And as you get more comfortable with this, then you can add more layers. You can add another gateway load balancer and another layer. You can go nuts. But yeah, this is a little bit closer to what I would recommend for folks, given that diagram that we saw at the beginning. So I sort of hand wave some of these designs. They're not exactly something you can go implement just based on these couple of slides here. So I'd recommend go checking out these other sessions that have a deeper dive into the architectures and some of the ways these things actually integrate and hook in with each other. Another thing you want to think about for availability is the limits. So in some cases, limits prevent you from scaling out higher, right? In some cases, if you hit these limits, it actually hurts your availability. So this first route is an example of that. If you send more than 100 routes over VPN or Direct Connect, we're going to drop your BGP session, which means you could have availability issues. Otherwise, just in terms of scale, you want to look at the amount of VPCs you have. If you're using things like Direct Connect, how many Direct Connect gateways and VPCs can you get to? If you're using a single hosted virtual interface, how do you scale that out? And so I've listed some of these limits out here that you want to think about. For transit gateway, it's similar. You want to look at your scalability of routes to make sure that we can keep all these networks up. So the one that I run into the most is with Direct Connect Gateway. You can send 20 routes from AWS to on-premises through the Direct Connect Gateway. And you connect up to 3 of those. So you can basically send 60 routes from Transit Gateway back on-premises. And you can send 1,000 routes back on-premises from Transit Gateway VPN. And so take a look at your network summarization and make sure you've got a plan there. As well for VPCs, if you're using VPC peering, maybe with a shared services VPC, you'll only be able to scale that up to 125. So we'll look at Transit Gateway beyond that. And then also, if you're using a lot of network load balancers, we can do up to 50 of those, plus interface endpoints and private link. So if you're doing large VPCs with lots of tenants and those kinds of things, you may want to watch those limits. So you don't have to memorize all this. I've got links. This will be published on Friday in a way that you can go and pause this slide or go and look at this later. So you don't have to memorize these links, and I don't think you will. But this will be available to take a look at. So yeah, let's talk about security. So security is also magic. And so let's talk about how we actually keep your network secure. So the first thing that we talk about is encryption. So last year, we basically said that any link outside of our physical control, including between data centers or availability zones or the backbone, is encrypted. So that helped a lot of big companies that were worried about security. If you're curious about the actual implementation, it's typically MACsec or AES 256. If you use things like cross-region VPC peering, that's actually encrypted again with one of our own encryption technologies that you can look into. As well, last year we announced the ability to do instance-to-instance encryption by AWS. And so if you're using the right AWS Nitro-enabled instances, we will encrypt that traffic on our network without any work from you. And you can go take a look at the instances that support that. It's typically the instances that end with N for networking. But if you don't believe me, you don't have to. If you're worried about these kinds of things, we say, okay, encrypt your own traffic. Encrypt your own traffic in transit, encrypt it in at rest, whatever you need to do. Typically for networking, we're about in transit. So use VPN, encrypt your own traffic with SSL or TLS. And we provide all those options for you to do that with things like network load balancer and application load balancer, et cetera. If you want to do encryption in transit from on-premises into AWS, and you're using Direct Connect, you have 2 options. Either one, you can get a public virtual interface, which means we will advertise all of our public routes to you. And then on the transit gateway, you create VPN. So you create the public virtual interface is the sort of underlay. You create a VPN over that. And then you can connect to as many transit gateways as you want over VPN. Each tunnel is limited to 1.25 gigabits per second. So if you wanted to get to something like 10 gigabits per second, you'd probably want to create something like 8 to 10 VPN tunnels. Otherwise, if you don't like the public routing, what you can do is you can create a VPN. You can create a VPC, put maybe some virtual routers or firewalls in there. Then do a private virtual interface, and then tunnel to those instances over the private virtual interface. And again, there's some more details on how to do those 2 things across blogs and some other places. Least privilege is always a big concept. As it defines to networking, it typically is making sure your developers are using well-defined security groups and that they're referencing other security groups, and someone's making sure that everyone's not just opening up everything to 0.0. Making sure that only the right people have the ability to make changes. So you can verify this stuff with AWS config, with service control policies if you're using organizations. Another model we came out with was called shared VPC, so that the infrastructure group can create the VPC, and then application groups can then be shared subnets, so they don't have to worry about network configuration, and they also can't make changes if you don't want them to. And so that's a good model for this privilege isolation. In terms of internet surface area, anytime you can remove internet access from something that doesn't need it, it's a big win for security. And so, you can remove internet gateways in cases where maybe you centralize the egress. So with Transit Gateway, with Gateway Load Balancer, with the AWS Network Firewall service, you can now centralize your egress easier than you've ever been able to do that before. Remove the internet where you don't need it and put it in one place where you can control it. Use private subnets. Don't make everything public if you don't have to. Plus, Private Link allows you to connect to different AWS services or partner services directly through an endpoint as opposed to over the internet. So as opposed to allowing internet access from a VPC, you can say, hey, if I just want to get to the Lambda APIs, I can put a Lambda private link in my VPC. It goes over our network instead of the internet to get to those things and prevents your internet sort of service area there. And also, automation is a big part of this. So humans cause most of your security issues. Anytime you take humans out of your loop, your network's going to become more secure. And so anytime you can take manually touching things out of the equation, you're probably going to get a security win. So using security groups instead of virtual appliances and distributing that out, or using reputable security policy across your VPCs. And now that all these security things we offer have APIs, it's easier than ever to automate it. And like using guard duty as opposed to maybe more heavy duty intrusion detection systems. You may find out that meets your requirements without having to send all your packets through a bottleneck. And yeah, so more detail, there's a session on this, which I would recommend you taking a look at. And yeah, so here's performance. Last year I said, hey, what would you like to see? I always read the feedback from these things, and I had some spinning geese in here with pineapples. People said more next year, so I've listened, and now there's more geese with pineapples. So if you have other hints, leave in the feedback, and love to hear what you're going to talk about. But the next one is, okay, so we've got a secure network that stays up. How do we make it fast? And a lot of this depends on basically the choices in technologies you make. And so Direct Connect, for example, is great for if you care about latency or very, very low packet loss, or you need private connectivity, or if you want really high bandwidth, like 100 gigs and higher, or even just 10 gig. Because like I said, VPN is 1.25 gigs per tunnel. You can cap out on that if you're doing a lot of traffic. But otherwise, with Transit Gateway, you can add those VPN tunnels together with equal cost multipath. And get up to 50 gigabits per second. So you can still get high bandwidth there. Otherwise, if you're using SSL, TLS, encryption, all this good stuff, do you need private connectivity? You can just go straight over the internet. And the internet's going to outscale all of these all day. So take a look at your security and performance requirements and make a choice there. In terms of latency, we can start at the very low level, right? If you care about microseconds, milliseconds, nanoseconds, there's things we can do inside the cloud. So there's things like the Elastic Fabric Adapter, the new N family of instances that have lower latency. If you're in like high performance computing or maybe some high-end machine learning and inference sort of workloads where you care about like microseconds, you can use placement groups, which make sure the latency and the boxes are as close together as possible. Sometimes then if you're talking about like tens of milliseconds, it's just choosing the right front door. So we have our content delivery network, which is CloudFront. We also have Global Accelerator and Accelerated VPN, which allow you to come in to the AWS network as soon as possible and then ride our backbone into the right region. And so all you have to worry about is getting to that edge location as fast as you can, and we handle it from there. And there's also, if you're using Direct Connect, just do the math and figure out which one of these Direct Connect locations is the closest to where you want to be to your workloads. Again, with Direct Connect Gateway, you can go all over the world. And sometimes it's just about choosing where that computing should actually happen. So last year we released Outpost, and so now you can put the workload directly in your data center if you really need to. We released local zones. So if you're in areas like Los Angeles, you can choose to get your workload directly in Los Angeles, even though we don't have a region there. And then otherwise just choose the right regions where your users are or where your latency requirements might be at. If you have sensitive applications that really care about things like packet loss, jitter, maybe 5G and some of those kinds of things, you're going to want to test your network connectivity. And so in this case, look at bottlenecks, do some testing, A lot of times it's just using bigger instances to determine that. And here's some references here. So we've got a whole bunch of links here to help you out with these sort of performance groups and performance type things. So yeah, let's see here. Operational excellence. This is a time to introduce you to my friend, Cat5. So how do you actually keep this network up and how do you keep it running? So there's some cases. I've already sort of harped on automation and using that. You can make some choices within your VPCs. So you can have a few large VPCs or smaller VPCs, or you can just make it all distributed. But either way, what you want to do is automate that no matter what you do. And those are going to have different types of automation requirements depending upon which choices you've taken. And so that means things like tagging, transit gateway attachments and policies, whether or not you want to do essentials egress, if you use VPC sharing, how are you going to share that out with Resource Access Manager? There's a bunch of different things you want to think about, but the real big story is just make sure that you think about automation as you design these things. And then operationally, you have to become comfortable with failure, right? So I already mentioned that Direct Connect has a toolkit that you can use to test. And so, the more you can understand that things will fail, and then that's okay, and that as long as we come back from failure and we detect failure quickly, that's more important than trying to pick the instance that has the most nines in it. And that's one of the sort of cloud computing operational things that you have to sort of onboard to. And so, yeah, that could be multi-site failures, on-premises firewall failures. I already went through a whole bunch of those different models in the reliability section. But operationally, you want to make sure you've tested these things. That's sort of the point here. And just, also, in a lot of cases, informed decisions, right? Sometimes you can use things that you're comfortable with, but more now than ever, we also have managed services. And so operationally, we can take a lot of the management concerns away. So instead of using a NAT instance, there's NAT gateways. Instead of managing a Bastion host, you can use Session Manager. Instead of managing routers, you can use Transit Gateway. As opposed to running your own bind and unbound services for DNS, we now have Route 53 inbound and outbound endpoints. So sometimes it's just about doing some research before you get into these things. And there's a time and case for any of these things. We just make sure it's informed. And then just monitoring, get familiar with CloudWatch, figure out your baselines. If you need to, you can run synthetics so you can test failures and bandwidth. And so this is typical sort of networking things. In our world, it's mostly CloudWatch. If you care about this type of failure domains and monitoring, it's just this session here. And so, yeah, the last case is now we're going to get rid of your cloud costs. Oops. All right, so let's take a look at some things that are expensive and I don't recommend. So if you're sending lots of data to S3 through a NAT gateway, don't do that. Use a VPC endpoint like gateway endpoints instead. So private link can actually save you quite a bit of data transfer cost. If you're referencing other applications by their public IP instead of their private IP, that's expensive. Don't do that. Use the private IP addresses. If you're using a distributed application that's in multiple availability zones, but the application doesn't know which availability zone everything else is in, and you're sending traffic all over the place in a full mesh, don't do that. Try to make sure that your application is AZ aware so that it keeps traffic within the availability zone. It also helps your cross dependencies for availability. And if you're sending large data transfer out to the internet, if you're doing a lot of transfer, take a look at CloudFront. So CloudFront has a cheaper data transfer alternative to sending traffic out to the internet. And so take a look at CloudFront if you have large data transfer. And then if you have unused NAT gateways, maybe when your developers just really like scripting all their infrastructure, and if you just have all these NAT gateways hanging out, not doing anything, that can add up. And so take a look at your NAT gateway cost and make sure you can centralize those or just turn off the ones that you're not using. And then just operationally, you want to make sure what your baseline is. So VPC flow logs allow you to see who's talking to where. You can run that through some of our analytics services like Athena or put it into Elasticsearch. So you can understand who's talking where, what are some anomalies, that kind of thing. And so here's the link on how to do this with Athena. We have a blog post on that. And then also AWS Cost Explorer helps you take a look at some of these issues as well. And so From it, other cost is like direct connect can sound more expensive up front because you have to hire a partner, you have to have a data center, but you can have, it has a lower data transfer out cost. So if you're doing a lot of data transfer back on-prem, direct connect can actually be cheaper for that. As well as making sure you have the right instance sizes. So if you can cut down some sizes on instance sizes, that's great, and EC2 Cost Optimizer might help you there. Otherwise, you also want to make sure that you're not using too many transit gateways or shared VPCs. Shared VPCs can actually help you reduce costs because of the way that they do data transfer. It's all within one VPC, and you sort of keep it within one area. If you want more detail, again, here's a link to the networking lens with EKS that goes through some of those details. There's also a cost savings lab from Well-Architected that goes to these issues as well. So yeah, thanks for the time. I really appreciate it. Hopefully this helped everyone. Again, submit your feedback. We take a look at all those things. And yeah, so be well and take a look at the Well-Architected Framework for all your applications. Thanks.